adding and subtracting rational expressions. Remember, irrational expressions are expressions with variables on top and bottom of the fraction. So remember, when adding and subtracting fractions, you have to have common denominators. We'll start with a really basic example here. We have 1/2 take away 5/6. In order to get common denominators, I need to figure out what I have to multiply the 2 by to make it look like a 6. If we need to, for bigger problems, we can actually factor that and say that 6 is 2 times 3. Well, if 6 is 2 times 3, that means I need to multiply the 2 times the 3, because that's the piece that's missing. Whatever I do to the bottom, I do to the top. Once I do that, I have a common denominator of 6, and I can write that as my common denominator. Now I have 1 times 3 is 3 minus 5, and that gives me negative 2/6. At the end, you always try to simplify or reduce. So negative 2/6 can be reduced top and bottom by 2 to give me negative 1/3. Now this was a subtraction problem, but for the bigger problems, we never actually subtract. We will always distribute the negative sign and then make an addition problem. What do I mean by this? I mean, here we have a negative sign. So instead of using a negative sign, I'm going to change this to a positive sign and distribute the negative through the right-hand side. So this negative was literally saying the entire fraction on the right was negative. What we're going to do is distribute that negative through to give us a negative 2x and a positive 3. We'll never actually do a subtraction problem because there's too many mistakes to be made. The next thing we need to do is look for common denominators. On the left-hand side, I have 5 times y. On the right-hand side, I have 2 times x. This one's pretty simple to find the common denominators. I multiply the opposite side by what they don't have. The 5y does not have a 2x, so I multiply it by 2x. What I do to the bottom, I always do to the top. And on the right-hand side, I have a 2x, but I don't have the 5y, so I multiply the bottom times 5y. And whatever I do to the bottom, I also do to the top. Now I'm going to have a common denominator of 10xy. On the left-hand side, I have 2x times 4x, and then 2x times negative 5y. On the right-hand side, it's a little more complicated. There's 2 steps here. We have to begin with the negative is being distributed, so I'm going to go ahead and distribute that. That gave me a negative 2x plus 3, but we're still multiplying that times the 5y. So then I'm going to distribute the 5y through, and that's going to give me a negative 10xy plus 15y. Now I look for any like terms. I see that I have like terms here. I have a 10xy and a 10xy. I can combine those. And we are finished at this point. Notice if that wasn't a 15, if that was an even number at the end, I could take out a GCF of a 2. However, it's a 15, so I can't take out a GCF. Now, they're also going to ask for any restrictions. So note that x cannot equal 0, because that would make your denominator undefined, and then y also cannot equal 0. Those would be your 2 restrictions on this. All right, let's do another one. In order to find the common denominator here, we're going to have to factor the denominators. So on the left-hand side, I have a difference of 2 squares. On the right-hand side, I already have a 2c minus 5. On the left-hand side, I have a 2c minus 5. So notice, what is the one piece that's missing? The one piece that's missing is the 2c plus 5, because I already have matching there. So I need one of each. That means on the right-hand side, I'm going to have to add that 2c plus 5. And whatever I do to the bottom, I do to the top. That's going to give us a common denominator of, on the left-hand side, nothing changed. It's still c plus 3, plus, now on the right-hand side, I actually have a multiplication problem here. So if needed, you stop and do your multiplication problem. Remember, I always teach you to do your multiplication top to bottom, just like you learned in elementary school. Now, if you don't remember how to do that, go back and watch one of the previous videos where we go over it. Now you're looking for like terms. Here I have a regular c and I have a negative 11c. Those are my like terms. And then I also have a 3 and a negative 40. Those are going to be like terms also. So now I can go ahead and rewrite this after combining my like terms. I still have a common denominator of, notice I didn't combine that back for the simple reason that I may be able to reduce later. So I'm going to leave that separated. Then I write 2c squared, combine my like terms gives me negative 10c, and then 3 and negative 40 gives me negative 37. As always, try to factor the top in order to simplify. The 2c squared minus 10c minus 37 is not factorable. So my final answer will be 2c squared minus 10c minus 37 over the 4c squared minus 25. I simply just multiplied them back. And don't forget to find their excluded values. And remember, these are actually your restrictions right now. We call them excluded values when we're solving. Take your denominator and set it equal to 0. Then solve it. And we get that our restrictions are x cannot equal plus or minus 2/5. And when I say x, I really meant to say c. All right, here's another one. It's a little bit easier because there's less on top, but a little more difficult because there's more on the bottom. Factor anything that can be factored on the bottom. I have an x plus 3, great. I have a 3x plus 9. That can be factored with the GCF, giving me 3x plus 3. And then I have 2x plus 6, again, can be factored with the GCF, giving me x plus 3. The other thing you need to do is get rid of that negative sign. We're not subtracting, we always add these. So this becomes a plus sign, and then we bring that negative up in front of the 9. So we have 6 plus a negative 9x. And the reason why we do that is if we have to distribute something, it's much better to have it written like this. Now go through and look for what's missing. I have an x plus 3 in all of them. That's great. Unfortunately, I have a 3 in the middle, a 2 on the end, and no numbers in front. So that means I'm going to have to multiply the first one by both a 2 times a 3. I'm going to have to multiply the second one by a 2. I'm going to have to multiply the third one by a 3. Well, 2 times 3 is 6. So whatever I do to the bottom, I do to the top. And then I have a 2 here, and so that needs to multiply times the top, and then a 3 at the end. Now, we're going to have a simple common denominator of 2 times 3 is 6, parenthesis, x plus 3. And we can check all the way down. 2 times 3 is 6, and then I have an x plus 3 all the way down. On top, I have 6 times 6 gives me the 36. Negative 9x times 2 gives me negative 18x. And then 3 times 1 is 3. We look for our like terms, which are simply 36 and 3, and that gives us negative 18x plus 39 over 6x plus 3. Now, if you put this in as an answer, you actually get it wrong. Let's take a look at the top. Can you take out a GCF on the top? And the answer is yes. I can take out a 3 out of the top. So this is what it becomes. Now I can reduce top and bottom. The 3 and the 6 can reduce to become 1 over 2, which gives me a final answer of negative 6x plus 13 over 2 parenthesis x plus 3. Now, this book actually wanted you to leave it factored like that, which I think is kind of funny. Some books will want you to go ahead and finish that out and say 2x plus 6. Realize it all depends on the book that you're working with. Now, don't forget, what are your excluded values? My only excluded value here is going to be x plus 3 equals 0, so x cannot equal negative 3. So that would be my excluded value or my restriction. And then my final answer would be negative 6x plus 13 over 2x plus 6. Now, this is a good one to do together because it's, well, quite frankly, big and complicated. First thing we want to do is factor the bottom. And when we factor the bottom, we see that we have no common denominators. Everything is different. So that means everything on the left-hand side needs to multiply times the right and vice versa. So on the right-hand side, I'm actually going to be multiplying x minus 3 times x plus 2 on both top and bottom. And on the left-hand side, I'm going to be multiplying the x plus 1 and the x plus 5, again, both on top and bottom. Which means my common denominator is everything. And again, the answer on this, they were okay with you leaving it in parentheses, and that's really nice. That way I don't have to multiply it out and get x to the 4th and x to the 3rd and all that. Realize what I did. I multiplied x plus 5 times x plus 1. That's the same thing as saying x squared plus 6x plus 5. So literally that's actually how I'm going to work this out. I'm going to multiply 3 times, and I'm going to rewrite this and then distribute it through. What that gives me is 3x squared plus 18x plus 15. Now I'm going to do the same thing on the other one. This x minus 3x plus 2, that's the same thing as x squared minus x minus 6. So I'm just going to rewrite that, and that way I can just distribute it through. Now I need to look for like terms. I have a 3x squared and a 2x squared that can combine. I have an 18x and a negative 2x that combine. And I have a 15 and a negative 12 that combine. So what I'm going to do is combine all those. And what that gives me is 5x squared plus 16x plus 3. Then I can take this and I can factor it. So on top that gives me 5x plus 1 and x plus 3. Now, why do I factor it? I factor it to see if I can cancel out anything with the bottom. Unfortunately, I can't cancel out anything with the bottom, so we leave it like that. And again, this question's okay with you leaving it in factored form, and the answer box should tell you what form they want. Then on the bottom, I still have not changed anything because we weren't allowed to cancel anything top to bottom. We have an x minus 3. Some people get too excited and say there's an x plus 3 and an x minus 3. They don't cancel. And that would give me my final answer right there. So this is a good one because it's a little more complicated. Now there's one more thing they wanted. They needed you to find the excluded values. So your excluded values are going to be anything that sets the bottom equal to 0. So I have x minus 3 equals 0, x plus 2 equals 0, x plus 1 equals 0, x plus 5 equals 0. And then after you do all that work, you figure out that x cannot equal negative 5, negative 2, negative 1, or 3. Notice I did put this in order from smallest to largest. Make sure you're reading the directions to see if that's how they want it or not. Now this problem is combining what we did last time with what we're doing this time. We need to combine like terms on top first, and then we can divide the two fractions. So the first thing we need to do is worry about the plus sign on top, because technically that's inside a giant set of parentheses. It's not written as is, but it's technically inside a giant set of parentheses. So we have to take care of Pemdas, which means inside the parentheses first. Now, in order to get a common denominator, I'm going to multiply the left side by 2. Whatever I do to the bottom, I do to the top. I'm going to multiply the right-hand side by x. Whatever I do to the bottom, I do to the top. And what this top is going to be is x squared plus 6 over common denominator of 2x. Now the original problem still has the x minus 1 over x. If we remember from before, when dividing fractions, you take the bottom and you invert and multiply. So what that means is the top stays the exact same. Then the bottom flips upside down and changes to a multiplication symbol. Before we go any farther, we look to see if I can cancel anything out. The x squared plus 6, he's not factorable. That's just what it is. But I do have an x and an x that I can cancel out. And that'll give me a final answer of x squared plus 6. Now the 2 is going to multiply times the x minus 1 and distribute through. And so that's going to give me 2x minus 2. We already know that the top can't factor, and we're finished. Here's another very similar problem. It's almost identical to the last one. It just looks weird. And so same thing. Deal with what's inside those invisible parentheses first. We need to take care of the addition, subtraction, and then we can do the inverting and multiplying. On the top left, I need to multiply by an x, top and bottom, and on the top right, I need to multiply by the w, top and bottom. Same thing on the bottom, times x times x times w times w. So I'm treating this like two separate problems. That gives me a common denominator of wx, and that also gives me a common denominator of wx. Then that gives me 3x plus 2w, and that gives me 2x minus 3w. Now we can invert and multiply, and what that looks like is the top is not changing. Luckily, they made this simple for us. We simply cancel out the wx, and that gives us a final answer of 3x plus 2w over 2x minus 3w. I realize these have the same letters and numbers in them, but no, they are not cancelable. All right, I want to go over this problem because it seems like it should be an easy problem, yet people often struggle with this. So it's the same idea as the last one, it just looks funny. What is the simpler form of y divided by 1 over xy plus 1? It might not look like it, but there's three fractions here. The y is over an invisible 1. We have 1 over xy plus 1 over, again, an invisible 1. So the first thing we need to do is take care of the denominator by combining like terms. The left-hand side has an xy, the right-hand side has a 1. So I need to multiply the right-hand side times xy. What I do at the bottom, I do the top, times xy. Now, just looking at this denominator, the next step for that denominator is going to be 1 plus, and then 1 times xy is xy over, and now I have a common denominator of xy. So that is the denominator. The top hasn't changed. There's still a divisible sign, and then there's still the y over the invisible 1. Now all I have to do is invert and multiply that denominator. So the y over 1 hasn't changed. It becomes a multiplication symbol, and I'm inverting this denominator, xy over 1 plus xy. Now it's a regular multiplication problem, and I can multiply straight across. Y times xy is xy squared. 1 times 1 plus xy is still 1 plus xy. I realize there's an x and a y on top and an xy on the bottom, but because of that 1 plus symbol, they are not cancelable. We cannot cancel those. This is my final answer. Well, it looks like a very strangely worded problem or strangely written problem is actually pretty easy as long as you do it one step at a time. Okay, last problem, and really because it's such a weird problem, that's why I want to run through it with you guys. First step is always pretty much the same. Factor those denominators. I have an x plus 4 is one factor. Then this is going to be an x plus 4 times x plus 4. And this is going to be an x plus 4 times x minus 4. So factor the denominators. Now remember, you need one of each factor in the denominator. The first one has a single x plus 4, the second one has two x plus 4s, and the third one has a single x plus 4 and an x minus 4. Now this is where things get weird and people start messing up. So we're going to go through this. The first one has an x plus 4, the second one has an x plus 4, and the third one has an x plus 4. We're good on that. Next, the second one only has an x plus 4, but neither the first or the third have that. So I need to add another x plus 4 to both the first and the third. So multiply by x plus 4. Whatever you do to the bottom, you do to the top. Next, the third one has an x minus 4. The second and the first do not have an x minus 4, and what that means is I need to add an x minus 4 to the second and an x minus 4 to the first. One more thing on here, remember we never use subtraction here, so I'm going to change this subtraction to an addition, and this becomes a negative x. Well, my common denominator is x plus 4, x plus 4, x minus 4. Well, if you have two x plus 4s, that's the same thing as saying x plus 4 squared. And then there's an x minus 4. Now the tops. The first one is 9 times x plus 4 times x minus 4. what I'm going to do is I'm going to take this x plus 4 and x minus 4 and multiply it out. And what that becomes is x squared minus 16. That's still being multiplied times the 9. So we're going to distribute that through. And what that becomes is 9x squared minus, and 9 times 16 is 144. So this, I'm going to highlight it so it's obvious. X minus 4 times x plus 4 gave me x squared minus 16. Then I had to multiply times 9. When I distributed that through, I got the 9x squared minus 144. Next, I had 7 times x minus 4. So I'm going to distribute the 7 through, and that's going to give me 7x minus 28. And then the last one, I have negative x times x and negative x times 4. And what that gives me is negative x squared minus 4x. Now I go through and look for things to combine. I have a 9x squared, and I have a negative x squared that can combine. I have a negative 144, and I have a negative 28 that can combine. And I have a 7x and a negative 4x that can combine. So we're combining like terms here. Our common denominator did not change. And then in the numerator, we have 8x squared plus 3x minus 172. Now the 8x squared plus 3x minus 172 is not factorable, which means this is our final answer. Our excluded values, or our restrictions, are going to be x cannot equal negative 4, and that would be there twice, or positive 4.